Hey everybody, this is Mr. Prevet. I'm going to be going over the 2023 FRQ number 5. It's a relatively easy one. I would say that mainly centers around derivatives. Um, I would say also a little bit of first fundamental theorem of calculus. So relatively easy, I would say, but we're still going to have a great time tackling it together. So I'm going to have the question over on the left so you can follow along there and check my work here on the right. But reading the question, we have a table of x, f of x, and g of x and their derivatives. And the question says, let the functions f and g be twice differentiable. The table shown gives values of the functions and their first derivatives at selected values of x. So we know our table, these functions are twice differentiable, so their second derivatives and first derivatives will exist. Now part A says let h be the function defined by h of x equals f of g of x. And it asks us to solve for h prime of 7 and show the work that leads to our answer. So let's go ahead and get started here. We know that h of x is equal to f of g of x. And we are trying to solve for h prime of x, so I would want to take the derivative of both sides. So on the left side, I would get h prime of x. On the right side, in order to take this derivative, I would use chain rule. And the reason is because I have an inner and an outer function. And when I have an inner and an outer function, I think chain rule. Chain rule for an inner and outer function is the derivative of the outer function, still evaluated at g of x, multiplied by the derivative of the inner function. So now we're looking for h prime of 7. So that would be f prime of g of 7 multiplied by g prime of 7. So now we need to go looking at our table, which fortunately has all the values we need, it looks like. We'll start out by looking at this g of 7. It says that g of 7 is equal to 0. So this will now be equal to f prime of 0 times g prime of 7. We have to be careful. When we get 0 for g of 7, we're not multiplying 0 by something that is the inner function here. So now we just need to evaluate these two. So h prime of 7 will equal f prime of 0, which is equal to 3/2, multiplied by g prime of 7, which is equal to 8. Multiplying these two together gives us a final answer of 12, which is the correct answer to part A. So a relatively easy question, challenging us to remember chain rule, and then also know how to use the table. So that was part A. Now moving on to part B, we see this question. It says let k be a differentiable function such that k prime of x equals f of x squared times g of x. And it asks, is the graph of k concave up or concave down at the point where x equals 4? So let's think about this. For part B, our derivative of k is equal to f of x, that whole function squared, times g of x. Now it asks us about a question about the concavity of the function k. We know that concavity is related to the second derivative of this function. So we will need to take the derivative of both sides in order to get the second derivative of k. Now, we have these two functions. I would be tempted at first glance to say, oh, well, we have a function raised to a power, so I can use chain rule or power chain, right? But we also have it being multiplied by this other function. So to start out, we are going to do product rule because the first step is these two functions being multiplied together. So I take my first function and multiply it by the derivative of the second function. And then I will add the derivative of the first function. Now this one we would use power chain or chain rule on because we have a function raised to a power. Now when I have a function raised to a power, I drop down my exponent. I will now have f of x raised to the 2 minus 1 power. It's just f of x to the first, or f of x, multiplied by the derivative of that inner function. And then that will be multiplied by g of x. Almost ran out of room on the paper. But that would be our second derivative. And it's long, it's winded, it's a challenge, but it is what it is. Now it asks us about the concavity of this function at x is equal to 4. So we need to evaluate our second derivative at 4. So that will equal f of 4 squared times g prime of 4 plus 2 times f of 4 times f prime of 4 times g of 4. So now we can look once again to our table and find these values. So starting out, looking at f of 4 is equal to 4. So this would be 4 squared times g prime of 4, which the table tells us is 2. It will be plus 2 times f of 4, which we know once again is just 4, times f prime of 4, which is equal to 3, times g of 4, which is equal to negative 3. 4 squared is 16, times 2, we get 32. And then this will become 8 times 3, which is 24, times negative 3, which gives us negative 72. So our second derivative at 4 is equal to negative 40. Now, the question doesn't ask us for the second derivative. It asks whether it's concave up or concave down. And I would say that this function is concave down because k double prime of 4 is less than 0. Because we know that when a function's second derivative is less than 0, the function is concave down. So that is our answer to part B. A little bit winded doing this product rule and power chain all combined, but overall, because we have the table, we didn't have to do anything too challenging. But let's move on to part C. Part C, we have an integral thrown our way. So we look at it. Let's check it out. It says, let m be the function defined by m of x is equal to 5x cubed plus the integral from 0 to x, sorry I wrote that kind of small, of f prime of t dt. And it asks us to find m of 2. Now, we already have the function m, so let's just plug in 2. I would get m of 2 equals 5 times 2 cubed plus the integral from 0 to 2 of f prime of t dt. Now, this first part, that will obviously just evaluate out to 5 times 8, which is 40. Now, the second part, a little bit trickier. We have to use our first fundamental theorem of calculus. And the reason is when I take the integral from any number a to b of a derivative, I know that I will get f of the first number minus f of the second number. And that is just a property of integrals. I take the antiderivative of f prime of t, I get f of t, evaluate it from 0 to 2 to get f of 2 minus f of 0. So now, once again, using the table to find those values, I get f of 2 is equal to 7, f of 0 is equal to 10. So 47 minus 10 is equal to 37. So m of 2 is equal to 37. It asked us to show our work. This is fantastic work, so we are completely done. So with that one, really, the hardest step was definitely using the first fundamental theorem of calculus to go from this integral to the evaluated form. But a relatively quick question in comparison, especially to part B. So now we're moving on to part D, and this is our final part to this question. And it asks us, is the function m defined in part C increasing, decreasing, or neither at x is equal to 2? So let me rewrite this function just so we can get a good look at it. F prime of t dt. Okay. So it asks us if the function is increasing, decreasing, or neither. Now we know that increasing functions happen when its first derivative is positive, right? So this would be m prime of x is greater than 0. A decreasing function would happen when our derivative is less than 0. And neither of those would happen if our derivative was 0 or, I guess, undefined at a point. So it seems like based on all of these, we need to take a derivative of this function. So starting out, the derivative of 5x cubed, I could just use power rule to get me 15x squared. Now, this second derivative, we are going to have to use another theorem of calculus, and that is the second fundamental theorem of calculus. We know that when I take the derivative of an integral evaluated from a to x, some function, it will just equal that function evaluated at x. So in this case, its derivative will just be f prime, because we have f prime of t, and I will replace t with x. So that gives us a very simplified form, which is really helpful because they ask us, is it increasing, decreasing, or neither at x is equal to 2? So we can evaluate this derivative at 2 to give us this, plus f prime of 2. 15 times 2 squared is 15 times 4, or 60. And f prime of 2 is negative 8. So we get 60 minus 8, and I get 52. So that is not my answer. Sorry, I circled it. But that is our first derivative, evaluated at 2. So I would say because m prime of 2 is greater than 0, our function m of x is increasing at x is equal to 2. So that would be our final answer, just giving a little bit of justification, just like the question asks us for. And to be clear, I feel like I didn't clarify this quite as well. This negative 8, this just comes from our table, where it gives us a list of values for f prime. So that is question number 1 I hope that helped. Overall, I would consider this FRQ one of the easier ones on recent AP tests. So we should definitely be shooting to get a higher score on this one if we're looking to succeed and pass our AP exam. But I hope that you guys have an amazing day, and I will see you guys soon.